Welcome to this video. Some children in different year groups have been asking about certain topics they're getting a little bit stuck on. So I've decided to go through 4 topics here, which you can see on the screen. That's it really. Let's go. So Roman numerals first. So here are the letters that we use when we do Roman numerals in primary school. I, V, X, L, C, D, M. Okay, so I just want to show you, because some people in year 3 have asked questions about Roman numerals. I just wanted to show you a little rhyme that might help you remember what these letters represent, what number they are worth, because this is what they are worth: 1, 5, 10, 50, 100, 500 and 1000. But you might not know this off by heart, and I personally seem to forever get a bit mixed up between L and D. So I'll show you a little rhyme which might help you remember these. It goes like this: I vote extra large Cadbury's Dairy Milk. So what we've done here is just made up a little rhyme that helps us remember the order of the letters. I vote, we cheated a little bit on extra because extra doesn't really begin with an X, but we used it extra anyway. Large Cadbury's Dairy Milk. So vote can mean choose, can't it? So it's like you're choosing an extra large chocolate bar. I vote extra large Cadbury's Dairy Milk. And how I use it is like this. I'll say the rhyme to myself and say, I vote extra large Cadbury's Dairy Milk. That gets the letters in order of size, because I is the smallest, M is the biggest. And on next to them, I'll just write 1, 5, 1, 5, 1, 5, 1. Just like that. 1, 5, 1, 5, 1, 5. Keep writing that. Then you just have to make sure things get bigger as you go down the list of numbers. 1, 5's bigger than 1, so that's okay. 1's not bigger. Make it 10 and it's bigger. So now we're going 1, 5, 10. That can't be 5 because it's not bigger. 50 is bigger than 10. This can't be 1 or 10. It needs to be 100. Just make sure the numbers go bigger as you get bigger as you go down the list. After 100, it's not going to be 5 or 50, it's going to be 500. And at the end, it's not going to be 1 or 10 or 100, it's going to be 1000. So that's what I do. Write down the letters, write down 1, 5, 1, 5, 1, 5, 1, and then you place just zeros on to make the numbers get bigger. And then you have a list of what all the letters mean. So if in year 3 you're struggling to remember what the letters mean, I vote extra large Cadbury's Dairy Milk. Write that rhyme out a few times, write those letters out a few times and the numbers, and you'll be pretty good at finding what numbers represent these letters. So that's a little bit of help for year 3 with that. And anyone else. Obviously you can use that in any year group, still use that in year 6. Let's move on to some money problems. Some people in year 4 have been asking about a bit of help with money problems. So we're going to do some how much change problems. How much change, get this into your heads that how much change means minus. Always going to be minus involved in the question if you're doing how much change. So how much change from £5 would you get if you bought a pen? Here's a mini little shop and there's a pen. How much change from £5 would you get if you bought a pen? So what you don't do, I'll do this in red because this is wrong. What you don't do, it is a minus, but you don't do this, 5 minus 1.42. You don't do that. You don't do 1.42 minus 5. No, you don't do that. You've got to be very careful with getting this right. So with a minus question in column method, which I'm going to use, you want to put the biggest number at the top. £5 is bigger than £1.42. So £5 will go at the top. How do you write £5 when you're doing column method? £5 and 0 pence. If you write it like that, and I know in year 4 you've only just started looking at decimals really, but if you do it like that, you can line up the decimal point like this, going down in a straight line. And that's what you do with decimal points. If you're adding or subtracting, you line them up. Even if you're dividing, you line them up. So £5 minus £1.42. So it's all about how you set up the column method. You've got to set it up in the right way. So let's do the column method. 0 take away 2 we can't do. I'm going to do this quite fast because you see morning maths all the time, don't you, for these Really important basic skills in maths. If I do my column method correctly, I get 3.58, £3.58. Well, right, let's carry on. £3.58 for that first question. Let's do another one. How much change? How much change from £5 would you get if you bought 3 pencils? There's the pencils. We're going to buy 3 of them. So when you're doing how much change questions, you have to find out what you've spent first and then do your minus for the how much change part. So we're buying 3 pencils. We've got to find out what that costs. So we can add that up. 55, do it down here. 55 plus 55 plus 55. This is all in pence. Okay, I'll add it all up in pence. So this is adding here, because this is going to be a 2-part question. We will have to do minus, because how much change is minus. But first we're doing adding. And I think we get 165p. How much change from £5 would you get if you bought 3 pencils? Well, the pencils cost us 165p. We've got £5. So be careful here, because this is in pounds and this is in pence. You have to be very careful about this. I'll change £5 into pence in this case. £5. £1's 100 pence, isn't it? £2 is 200 pence. £3 is 300 pence. £4 is 400 pence. And £5 is 500 pence. So I've changed my pounds into pence so that it'll match up with this 165p. Then I can take that away. It's also possible to make sure have both of them in pounds. It's just a different way of doing it. I've got both of them in pence. They must be in the same unit, which means they must either both be pounds or both be pence. Let's do the takeaway. I'll do this quite quick because I know you have a lot of good practice at this. And what do we get? 335. What's that? 335 pounds or 335 pence? It is 335 pence. You either put a P on the end or a pound sign at the front. You don't ever put both. It's only one or the other. You must know what you've been working in. And I was working in pence this time. If you did it in pounds, you would have got £3.35 because that's the same. And that would also be correct. Let's go on to the next problem. How much change, this is a minus again, from £10 this time, would you get if you bought 2 sharpeners? We're getting 2 sharpeners. They're in pence. Let's add them up in pence. 38 plus 38. So we do our column methods. 76. I'll put a little p on the end just to remind me that's in pence, not pounds. 2 sharpeners wouldn't be £76, would it? That'd be too much. It's 76 pence. How much change from £10? So what's £10? I'm going to have to change that into pence because £10 is in pounds. 76p is in pence. I'm going to change the £10 into pence. You might know what it is, but £1 is 100 pence, £2 200 pence, £3 300 pence, and so on. £9 900 pence. £10 is actually 1000 pence. 1000 looks like this. I'll write it higher. 1000 means you're going to have 10 in the hundreds column. So that would be 1000. Okay. I know there's 1 in the thousands column, but you can say that's 1000, or you could call it 10 hundreds. Anyway, 1000 pence is what is in £10. £10 is 1000 pence. £9 is 900 pence. £10 is 1000 pence. Take off 76, that's right over here. And we'll do our column method for takeaway. All the borrowing you have to do across here. I know you've been doing a lot of work in year 4 on subtraction. And if you're still struggling with that, keep practicing on the morning maths. We get 924. Is that pounds or pence? Hopefully you know it's pence. If you did the whole thing in pounds, you should have found £9.24. That's the answer for that question. One more problem in year 4. Well, this is for any year group really, but year 4s were asking about this. One more problem for money problems. How much change? A minus. As you can see, we often have to do plus first to find out what we've spent, and then we'll do a minus afterwards. How much change from £10 if you bought a pen? Get the pen. And 2 pencils. Okay, 2 pencils. So if I'm going to add up pens and pencils, you've got to be careful because pens is in pounds here, pencils is in pence. So what shall I add them up in? Well, you can choose. It doesn't matter. I'll go for pence. 55p plus 55p, that's the 2 pencils. And then £1.42 is 142 pence, isn't it, if I change it into pence? So I'm adding everything up in pence. I chose pence. Could have chosen pounds. And I get 252 pence. How much changed from £10 if you bought a pen and 2 pencils? Well, I worked out what I spent, 252p, and I'll take it off £10, which we saw in the last question was 1,000 pence. 1,000 pence, take away 252 pence. Let's see what we get. Lots of borrowing. You often have a lot of borrowing or helping in these how much change questions. 0 at the front, which I don't need. So 748, is that pounds or pence? It is pence, isn't it? 748 pence, which is £7.48. So that's money problems. Let's move on to something year 5s have been asking about, but it still applies to any year group really. Time problems. Let's get going with these time problems. A cake, well, in fact, before we get going, just remember, most things in maths, when we were just doing plus and minus, things often tend to be out of 100. A lot of things tend to be out of 100. But what you've got to remember with time is that there's not 100 minutes in an hour, is there? There are just 60 minutes in an hour. So things are often out of 60 when you're dealing with time. And that's going to be very important in these problems. So first one. A cake started to cook at 4:30 p.m. and took 35 minutes to finish cooking. At what time was it finished? So I do number lines for this. I'd recommend number lines for this because time problems, when you're adding, and we are adding here because we're adding some time on, but when you're adding with time problems, column method is going to go wrong because column method works in tens and hundreds, doesn't it? It doesn't work in 60s. So although we might occasionally use it a bit to help us with these problems, we've got to be really careful with it. So a cake started to cook at 4:30. That's when it started. I'm going to do a number line from 4:30. It took 35 minutes, so I'm going to add on 35 minutes. That's what I'm going to be doing, adding on 35 minutes. At the moment, we've got 4:30, the time, 4:30 p.m., haven't we? So what you want to do is add these minutes on in chunks if you're having trouble with this. Some of you might just know this answer straight away, but a lot of the time, people don't know, and you need to add on in chunks. What you want to try and do is jump to the next hour. So if you're at 4:30, how many minutes is it till the next hour, which is 5 o'clock? I'm going to jump to 5 o'clock. How many minutes is it from 4:30 till 5 o'clock? Well, there's 60 minutes in an hour. 30 plus another 30 is 60, and that gets us to the hour, okay? So I would add on 30 minutes out of the 35. Takes us to 5 o'clock. We've added on 30 minutes. We've just got 5 minutes to add on, haven't we? What's 5 o'clock plus 5 minutes? It's not 5:05, is it? It's 5:05. Be careful with that. It's 5:05. And we have our answer, 5:05 p.m. Not too difficult. So what I did there is I jumped to the next hour. That took 30 of the 35 minutes, and I jumped another 5 minutes. With lots of practice, this is what you're doing in your head. If adults are working with their cooking and things, they often work out this kind of thing in their head. Because with practice you can, depending on how difficult the question is. Next one. A match started at 1:50 p.m, let's write that down, and lasted 43 minutes. Do a number line. That was nice and straight, wasn't it? A match started at 1:50 p.m. and lasted 43 minutes. So I'm going to go from 1:50, and I'm going to add 43 minutes. That's what I'm going to do, add 43 minutes. But I'm going to jump to the next hour. I'll soon be on the next hour at 1:50. The next hour from 1:50 is 2 o'clock, isn't it? How many minutes from 1:50 till 2 o'clock? And don't say 50, because time's not out of 100. Time is out of 60, isn't it? So 1:50, it's just 10 minutes to get to 2 o'clock, isn't it? Just 10 minutes to go from 1:50 till 2. I'm trying to add on 43 minutes. I've just added on 10, so I've got 33 to the left to add on. You don't have to do this bit in red. It's just something I do sometimes to remind me. It's very easy to add 33 minutes on to 2 o'clock because we're not adding more than 60. We're not going to go past the next hour. 2 o'clock, add on 33 minutes is 2:33. And we have the time for our match finishing. We added on 33 minutes. So these two jumps that we did 10 plus 33 is 43 minutes. So we added on the 43 minutes that we needed to, and we got to 2:33. Sometimes your parents might do this when they work out what time to pick you up from matches you play and things like that. Next one. A lesson started at 10:45 a.m. and lasted 50 minutes. This is another very similar problem. 10:45, I'll put it on the start of the number line. It's lasting 50 minutes. At what time did the lesson finish? Now, most of these questions, they're going to jump over the hour. They're going to go into the next hour because that tests your knowledge, doesn't it? That's what makes it hard. That's what makes sure you know that there's 60 minutes in an hour, not 100. So what's the next hour after 10:45? It's 11 o'clock. How many minutes is it from 10:45 to 11? Well, from 10:45 to 10:50, that's 5 minutes. And then till 10:60, which isn't a real time, but 10:60 is what would be 11 o'clock, isn't it? It changes to 11 o'clock then. It's 15 minutes. If you're not sure, you just do 60 take away 45. Because time, do the borrowing, time is out of 60. So this is a 15-minute jump. We got to add on more than 15. What are we adding on? 50. 50 we're adding on. Now we've already added on 15. If you need to, you can do a little column minus to say, well, we already added on 15. What have we got to add on? I think I'm doing the same thing I just did a minute ago, or very nearly. Oh, not quite, no. 35 minutes left to add on. See, we were trying to add on 50 minutes. We've already added 15. We've got 35 more to add. It tells you the next jump will be 35. The next jump, you don't have to worry about going across the hour or anything. It's not going to reach 12 o'clock, is it? It was 11 o'clock plus 35 minutes is just 11:35. We haven't got to 12 o'clock yet. We've got our answer. 11:35 is when the lesson finishes. Let's do 3 more problems, going backwards basically. A cake finished cooking at 3:20 after 30 minutes in the oven. At what time did the cake begin cooking? So I know what time it finishes now. I don't know what time it starts. So 3:20 finish. We have to go back 30 minutes, minus 30 minutes. But it's going to be difficult. Excuse me. It's going to be difficult because we're going to have to go past the hour again. You can't just do column method for minus for this because it will go wrong. You can try if you want, it's going to go wrong. So we've got to take off 30 minutes. So I'm going to go back to the hour before. The hour before 3:20 is 3 o'clock, isn't it? You can probably tell quite easily that we went back 20 minutes. So we went back 20, but we actually have to go back 30. So we just got to go back 10 more, haven't we? Because 20 and another 10, it's red this time, 20 and another 10. In total, we've gone back 30. What's 10 minutes before 3 o'clock? Well, if you need to, you just do 60 take away 10, and it will tell you that it will be 50. It will be 2:50 because 2 is the hour before. So jump to the hour before. In this case, previous questions, it was the hour after. And that just makes it much easier to get yourself the right answer. What time did the cake begin cooking? 2:50. Let's go on to the next one. A 40-minute match finished at 2:05, so we've got the finishing time. When did the match start? They want the starting time. We've got a finishing time, 2:05, 40 minutes before that. So, well, I'll jump back 5 minutes. Why will I do that? Because 2:05, I can get back to nice, easy 2 o'clock. We're trying to jump to easy things, and 2 o'clock's much easier than 2:05. That was 5 minutes back, wasn't it? We have to go 40 minutes back. We're supposed to be going 40 minutes back. I already went 5 back. That leaves me 35 more to go back, doesn't it? So I've got to go 35 minutes before 2 o'clock. Hours are out of 60, so you can do 60 minus 35 if you need to. You might not need to do this working. You might know what it is anyway, but it's going to be 25. If we jump back again, we jump back the other 35. I've done the workings, haven't I? 60 minus 35 is going to be 225. You can see with our jumps, 5 and 35 together make 40, and that's how far we had to go back. This doesn't look right to me, to be honest. I hope you spotted my mistake. It's not 225 that it starts, is it? It's 125, because 225 would be after the match finished. So 2:05, I went back 5 minutes to 2, went back 35 minutes, and it's 1:25. Try and spot your mistakes like I did. Luckily I did spot my mistake that time. And let's go on to one more problem. After 6 hours, activities ended at 3:30 p.m. When did the activities start? We know the finishing time, 3:30 p.m. We've got to go back 6 hours, okay? So I think it's quite, I could go back an hour at a time, but it's quite easy to go back, well, seems easy to me, to go back 3 hours. So I would go back 3 whole hours. I'm in hours this time. 3 whole hours. What's 3 hours before 3 o'clock? It's 12:30, isn't it? Does that make sense? Because if you go back 1 hour, it's 2:30. 2 hours, it's 1:30. What comes before 1:30? 12:30. You know how clocks work. It goes to 12 in the middle of the day, and then we start again, don't we? And then I'll just go back the other 3 hours. 3 hours before 12. So we don't have to change the minutes here because there's no minutes changing really. It's just exact hours. Go back 3 hours from 12 is 9:30. But just one thing to be very careful with. We were on PM when we started, but notice how we've gone back through the middle of the day. We've gone back into AM. So the answer is actually 9:30 AM. So don't get tricked by that. So answer to our last problem, 9:30 AM. I would definitely recommend the number line method for time problems because they just don't work in the same way as normal maths. So you can't really use the column methods in the same way. Let's go on. This is for year 6 really, or perhaps very, very confident year 5s. Decimal long multiplication. One of the harder things we'll do. So with decimal multiplication, I don't like writing it out in many ways because you don't write it out correctly. You actually don't line up the decimal point, which is very weird because in plus and minus and divide with decimals, you do line up the decimal point. But times is different. It's a bit wrong and you just don't do it. You just don't line up the decimal point. You do it almost as if there's no decimal point and then you worry about the decimal point at the end. So I've lined it up as if there's no decimal point. You can put them in then after. Anyway, now we've lined it up incorrectly but correctly, we can do our method. You remember the long multiplication method, 0 on the second line down. So first we do 2 times everything. 2 times everything. I might do this in, I'll put the 2 in a different colour just so you know what I'm doing. First I'm going to do 2 times everything. 2 times 6 is 12. 2 times 3 is 6 plus 1 is 7. 2 times 4 is 8. So we've got that. And then we've dealt with the 2, that's been used. Now we've just got to do 5 times everything. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. 5 times 4 is 20, plus 1, 21. I like to cross out these little carried ones so I don't accidentally use them again. Then add up my 2 answers. This isn't in the morning maths quite yet, is it, long multiplication, but it is coming. It will be in the morning maths going forward. I know you've done it a bit in class. So I've got 22,672. That's clearly not the answer to that. What you have to do is count the decimal places in the question. That means digits after the decimal point. 1, 2, 3. And then make sure there's 3 in the answer. 1, 2, 3. So it tells you the decimal point must go before that. 22.672. Let's do one more of these. Very similar, but not the same. 35.2. So it happens that the decimal point lines up this time. Sometimes it will, just because of how many digits were in each question and where the points were. But I'm not deliberately lining up the decimal point. You're actually right aligning the numbers, which means down there, right aligning them. Let's go on to working out the answer. 3 times 2 is 6. 3 times 5 is 15. 3 times 3 is 9, plus 1 is 10. The next line, 4 times 2 is 8. 4 times 5, 20. And 4 times 3, 12, plus 2 is 14. I know this can be a bit tricky because long multiplication is still quite tricky for a lot of us, isn't it? In year 6 at this point. It's one of the harder things we have to learn. Practice is what you need. Practice. Keep doing it in the morning maths. As the weeks go past, you'll be doing long multiplication. and that'll be the practice you need. This is not the answer because we have to get the decimals sorted out. There's 2 decimal places in the question, so 2 in the answer. Notice how the decimal point is not lining up with the ones in the question, okay, because often it won't. Sometimes it will with these decimal multiplications, but often it won't. 151.36 is our answer. Just 2 more things to look at for year 6. First, I just want to show you the 3 types of remainders, what I might call them. 25 divided by 4. There's 3 ways of doing this question really. We use the bus stop usually for division. 25 divided by 4. So I'm just going to sing my 4. Well, 4 doesn't fit into 2. Carried a 2. Sing my 4s, but don't go past 25. 4, 8, 12, 16, 20, 24. I got 6. But did you notice I only sang up to 24? So I have remainder 1. So you could write 6 remainder 1. So 6 remainder 1 could be the answer. I'm actually going to get 3 different answers to this question. There's your remainder answer. I'll do it again. 25 divided by 4. 4 into 2 is 0, carried a 2. 4, 8, 12, 16, 20, 24 is 6. We have remainder 1. But what you could do with that little remainder 1, you could turn it into a fraction, which means you would just write it, and then you put it over this number. Just put it over 4. 6 1/4. 6 1/4 is also correct. In this case, that remainder 1 was worth 1/4. There's another way of doing it. And the third way of doing it is the decimal way. 25 divided by 4. We know it's not going to work exactly. We've seen that on the last 2. We know it doesn't work exactly. So it might work exactly, though, if you made it 25.0 or 25.00, because that's still 25 point nothing, isn't it? That's still 25. You haven't changed the number. You just put 0.00 on the end. Let's see what we get if we do the decimal version. 4 into 2 again is 0, carried a 2. 4, 8, 12, 16, 20, 24 is 6. That remainder 1 that we used to get now just gets carried on. We just keep going. How many 4s in 10? 4, 8 is 2. Remainder 2. We just carry on with the remainders. And how many 4s in 20? 4, 8, 12, 16, 20 is 5. We get, 6.25. So there's our decimal answer. 6.25. 3 answers are actually all correct. Now, we weren't doing a word problem here, were we? We're just doing a number problem. When would you use these different answers? If you were dealing with sharing out people into groups or sharing out children into classes, you would use a remainder because you don't want to chop people up, do you? So you would use a remainder. If you were dealing with cakes or pizzas or something, you would probably use fractions because that's what we usually use when we're chopping up cakes or pizzas. And if you were dealing with money, you would use decimals, wouldn't you? I would often use, if I had no other choice, I would usually go for decimals as well. So this would be my normal choice, unless the word problem was talking about cakes or pizzas, dealing with fractions, or if it was dealing with people or animals or things you don't want to chop up into fractions or decimals. So 3 different answers are all the same. One of the most important skills in maths, I think, is to know that 25 is 25 point nothing. That can really help you with a lot of questions. One last question. This one is in decimals already, so I'm definitely going to be given a decimal answer. The decision is made for me. I'm not going to do a remainder or a fraction if it's already in decimals. Divide this by 5. Just want to show you how to deal with a small problem that you get in this question. How many 5s in 4 is 0, carried a 4. How many 5s in 45? That's 9. How many 5s in 8? 1 makes 5, remainder 3, okay? I'm not going to put R3 on the end. This is decimals already. Did you know that 4.58 is the same as 4.580? Because it's after the decimal point, we're not changing the number at all here. My remainder was 3, wasn't it? It might work now. How many 5s in 30? 5, 10, 15, 20, 25, 30 is 6. I forgot one very important thing, which is line up your decimal point in division. And we get 0. That is supposed to be a full stop-ish. Well, it's not a full stop, it's a decimal point. It looks like a full stop. 0.916. Okay, so you can place that 0 after a decimal point, and it helps you get to the end of the question. Just in case you needed that little tip. Year 6, really, this last one was for, wasn't it? Thanks for listening, everyone. Next week, I'll probably be back with a few more tips on things you've been asking about. So see you then.